All right, today we're taking a huge leap into a world that promises to completely rethink the very boundaries of calculation. We're talking about a technology that could literally change, well, everything.
You know, the computers we use every day, they're incredible. They are absolute masters at solving problems we already understand how to solve. But what about the really, really big problems? Things like curing diseases that have stumped us for decades or tackling climate change. That's where we hit a wall. And that's exactly the leap quantum computers promise to make, to start solving problems we once thought were completely impossible.
The source material we're digging into for this explainer dives right into this fascinating paradox, both the unbelievable promise and the pretty serious challenges that come along with this new kind of computing.
So, to really wrap our heads around this quantum leap, we have to step beyond the simple digital world of ones and zeros that we all know and love. The rules are about to change.
Okay, here's the fundamental difference. Your phone, your laptop, they all run on bits. And a bit is basically just a tiny light switch. It's either on, which is a 1, or it's off, which is a 0. Simple. Quantum computers, though, they use something called a qubit. And a qubit isn't like a switch, it's more like a dimmer dial. It can be all the way on, all the way off, or, and this is the crazy part, it can be both and everything in between, all at the same time.
This dimmer dial capability has a name, and it's a really mind-bending quantum principle called superposition. This right here is the secret sauce. It's what gives a quantum computer its almost unbelievable power. Because a single qubit can hold the values of both 1 and 0 at the same time, a quantum computer can explore millions of possibilities at once. It's like it can check every possible path in a maze simultaneously. That's a scale of processing that's just completely out of reach for any regular computer.
So this ability to explore so many realities at once, it's what opens up this staggering potential. So what does that actually look like in the real world? Well, imagine being able to simulate incredibly complex molecules to design new, life-saving drugs in days instead of decades. We could potentially cure diseases that today have no treatment. Or think about logistics, solving optimization puzzles so complex that they could untangle our entire global supply chain, making it perfectly efficient. This isn't just a small step up. We're talking about a full-blown revolution for basically every industry you can think of.
But, and you knew there was a but, this incredible power also brings an incredible risk. This is where the story takes a bit of a darker turn, revealing the threat quantum computing poses to our entire digital world as we know it.
Let me put it bluntly. Pretty much all of our secure data, your banking info, private messages, everything, is protected by encryption. And that encryption relies on math problems that are just too hard for classical computers to solve. A powerful quantum computer, though, it could shred those codes. Not in years, not in days, but in a matter of hours.
And just think for a second about what that really means. The entire foundation of our modern, secure world, from financial systems to secret government communications and national defense, is built on a lock that could suddenly be broken. All of it becomes vulnerable.
So, as you can imagine, this threat has kicked off a global race against the clock. Governments, security agencies, they are all scrambling to develop and roll out new quantum-resistant encryption standards. They're basically trying to invent a new kind of digital lock that's strong enough to withstand a quantum attack before the old one gets picked. Now, before you panic, it's really important to understand that building these code-breaking machines is fantastically, almost impossibly difficult. There are enormous engineering hurdles that scientists are still trying to figure out.
And just to give you an idea of how hard this is, qubits are incredibly delicate. The slightest little vibration, the tiniest change in temperature, can just throw them into total chaos. So to keep them stable, these processors have to be kept in a deep freeze at temperatures colder than deep space. We're talking just a tiny fraction of a degree above absolute zero, which is the coldest temperature that's even theoretically possible.
So what's the bottom line for us? Well, the key thing to remember here is that widespread commercial quantum computers are not going to be replacing our laptops and phones anytime soon. So yeah, your laptop is safe for now. We're still years, maybe decades, away from this tech hitting the mainstream.
But even with all those crazy challenges, the arrival of the quantum era is pretty much seen as inevitable. It's really not a question of if it's going to happen, but when. And that brings us to the core tension of this whole quantum revolution. If we want to harness this technology responsibly, we have to start preparing for it now. We have to be ready for the unbelievable breakthroughs that will improve our lives, but we also have to build our defenses for the massive security challenges it's going to create.
So we're left with this one final massive question.
A technological revolution is on the horizon. It has the power to solve humanity's biggest problems, but also create some of our biggest risks. The quantum era is coming. The only question left is, are we ready for it?